Okay, so let's talk a little bit about the framework for a for loop. The for loop is always executed from the top of the code cell to the bottom of the code cell. By the way, as far as I know, it's impossible to split a for loop over more than one cell. So when you have a for loop, just don't try to put it over more than one cell, just put it in a single cell. Remember that when you write a notebook, it's a single computer, the whole notebook is a single computer program, and if you restart and run all, it starts right at the top and it executes the cells one by one, and in each cell it executes the lines one by one. So when it gets to the for loop inside a certain cell, it will execute that for loop and then carry on with the rest of the code. Right, so that's what is explained in this, and then this is trying to explain it in a graphical way. So what we have here tries to represent the Python code that you may have preceding the for loop. So you may have various calculations you want to do before you want to go into the for loop. So that will be sitting above the for loop, and it of course will not be indented unless it can actually be indented if this sits within something else which calls for indentation, like a function, for argument's sake. You could actually write a function with a for loop inside the function, and in that case this code will be indented 4 spaces because of the fact that it's a function. That will of course mean that this here will now be indented 8 spaces. But okay, forget about that possibility for a moment. Let's assume that this code here is the main program, the calling program. Then it will not be indented, and then you reach the start of the for loop, indicated by the for. Val is now your variable, or the value that's going to change every time you go through the for loop. For val in, so the for and the in is always there. Well, the val also, but the val is a name that you can choose it. You can choose a different name there. But the for and the in cannot be changed. And then you need to have a sequence of values that this val needs to take, every time it goes through the loop, like an array as we had before, or a list or a tuple, or you can even generate the sequence right there using computer code that will generate a sequence. That is also possible. Then you've got the colon, as we said before. Then after that you've got the indentation, and the indentation identifies how many lines are part of the function. And the execution will then follow this arrow, just like here. This arrow indicates the way that the code is executed from the top to the bottom. Then in the loop, it executes from the top to the bottom. Once it gets to the bottom, it goes back to the top of the for loop, and it repeats this every time for a new value of val according to what is in the sequence, until it's completed that for the last value. So once it accepts the last value, and it's completed going down the code for the for loop with the last value, it then exits the loop, and then it carries on with the code below the for loop that is not indented, in the case where this is the main program, or in the case where this for loop may be inside something like a function. It will of course carry on with a code that is less indented by 4 characters below it. Right, so that's the way that the for loop works. So this sequence here it says it must be an array, a sequence of numbers, but as I've said before, it doesn't need to be an array, it can be a list or a tuple. And also it doesn't really need to be numbers. You can even have, let's say, an array of strings. You want the thing to go through a for loop, and the first time it goes through the loop, you want to select John. So the val will then be John, which is a string. And the second time you want it to be Peter. So let's say it's John, Peter, Mary. Let's say we're going to write a loop with just four different values. So then we create an array or a list with John, Peter, and Mary. Is that what I said? And then if I then construct the for loop with that as my sequence, the first time it'll go through the val value, this value here, will then be a string. The first time it will be John, the second time it will be Peter, the third time it will be Mary, right? So it doesn't need to be a sequence of numbers, but for us as engineers, normally it will be it will be a sequence of numbers for doing calculations. The indentation or the white space in front of the code tells Python it's part of the for loop. The code inside the for loop is repeated before the code below the for loop executes, and each repetition of the loop implies that the name val is assigned to the next value in the sequence, whether it's an array or a list or whatever. So you can think of a for loop as it says to the computer, for each value in the sequence, repeat the following. That is, in a certain sense, stating a for loop in human language, right? What is at this square bullet. So you can also think of it that the for loop iterates or steps through the values in an array or a list, or in other words, in the sequence, from the start to the end. Now this is important. It means that the for loop is used to repeat code a known and fixed number of times. Now this may not make too much sense now, but in 1 or 2 lectures we also will talk about a different loop, which is called the while loop. Now in the case of the while loop, you do not know before you start how many times it will go through the while loop. So sometimes when you're in a situation where you want a repetitive calculation, but you do not know beforehand how many times it needs to go through the repetitive calculation, you'll use a while loop. So the for loop is used when you know up front you want to go through the loop 10 times, for argument's sake. So that means that in your sequence you'll have 10 values, right? And it's known, and it's of course a fixed number of times, namely the length of your sequence array or your sequence list or your sequence tuple. Okay, so let's look at some illustrative examples. Let's say we want to print values in an array to the screen one by one. But we'd like to do the repetitive calculations of the same nature, like for instance Gaussian elimination. In Gaussian elimination, have you done Gaussian elimination? We've got multiple equations. Let's say you've got 5 equations and 5 unknowns, and you can solve for the unknowns using Gaussian elimination. Now that's a repetitive calculation. It's a very good example of where you would use, in fact, a double for loop, a nested, 2 for loops, one nested in the other. But okay, we're not going to discuss that, but this is just an example of where you're going to use this. I made an error. I thought that we're going to now illustrate this, but we're certainly not going to illustrate it. It's just an example for the purpose of showing this.